Good day and welcome to Big Bad Tech. I'm your instructor Jim Pytel, and today's topic of discussion is the 4-band resistor color code. Our objective is to learn the 4-band resistor color code and use it to interpret resistor values. A resistor is a component that resists, controls, or otherwise opposes the movement of electrical charges. This movement of electrical charges is known as current, where current is the effect established through a conductive path by a voltage differential between 2 points. Without resistance, current would be an uncontrolled, potentially dangerous movement of charges. The oppositional strength of a resistor is the measurable quantity of resistance, quantified in units of ohms. More ohms, more resistance, more opposition would yield a small current for a given voltage. Less resistance, less opposition would yield larger current for the same given voltage. This important cause-effect and opposition relationship is known as Ohm's law, an important topic we'll spend another entire lecture on in the very near future. Resistors come in several different values, varieties, and shapes, but the one you'll most likely gain early exposure to are mass-manufactured 2-terminal devices that come in certain standard size resistance values and power ratings. The small physical size of some resistors prevents manufacturers from printing the nominal or nameplate value on the side using numbers. Small resistors therefore typically employ a 4-band color code, which serves to quickly identify the value of the resistor in question. Sadly, more often than not, the interpretation of the 4-band resistor color code is employed in lab environments in checking the work of your lazy lab partner. A not insignificant number of troubleshooting scenarios I've witnessed during the course of my experience as a lab instructor simply boils down to the sheer laziness of an individual that doesn't check if they're using the correct components. If the value is written right on the resistor, just read it. You'll be glad you did. The 4-band resistor color code is not that hard to learn, and you'll find it extremely handy once you've got it down. It does have its idiosyncrasies, though, and once you learn to identify and avoid these pitfalls, you'll be surprised how anyone ever lived without it. Speaking of common pitfalls, before we introduce the 4-band resistor color code, remember engineering prefixes, where a kilo is 1,000 or 10 to the 3rd power, a mega is a million or 10 to the 6th power? Remember those? Remember how handy engineering prefixes are at expressing, writing, and reading unusually large or small numbers? Well, forget them. The 4-band resistor color code has nothing to do with engineering prefixes, so you may as well forget them. For now. We'll come back to how engineering prefixes and resistor values relate in a moment. I had to get that out of the way first because a common pitfall I've observed in using the 4-band resistor color code is the misguided notion that it has anything to do with engineering prefixes. The 4-band resistor color code has nothing to do with engineering prefixes. It's a secret code, and I'm going to let you in on the secret. Let's talk about the significance of the colors first. The colors represent numbers. The color code is as such. Black is 0. Brown is 1. Red is 2. Orange is 3. Yellow is 4. Green is 5. Blue is 6. Purple is 7. Gray is 8. And finally, white is 9. In some special case scenarios, utilize gold and silver. Let's just ignore gold and silver for now. Realize that the numerical scale does not start at 1. It starts at 0 and goes to 9. Remember this. There's a common mnemonic device out there used to remember the order of the color scheme employed by the 4-band resistor color code, but it's a little racy and obviously isn't in common use today. If you're a pervert and you want to look it up and use this dirty ditty, by all means, pause the lecture and look it up. Don't be surprised, however, when an evolved secular humanist knees you in the genitals for offending their delicate political sensitivities if you use it in front of them. I generally don't like using mnemonic devices. My preferred way of remembering the color scale is to visualize it as a rainbow bookended by a dark and a light end. What's the darkest color you can think of? Black. How much blacker can you get? The answer is none. None more black. Get it? Next darkest color. Brown. Now go through the rainbow. Red, orange, yellow, green, blue, purple. No, indigo is not a color, and there's no such thing as violet. They're both purple. Now what's the second lightest color you can think of? I don't know, maybe like a light shade of gray? Yeah, I need to work on that one. Finally, what's the lightest color you can think of? White. There you go. 10 colors, 10 digits. It starts at 0. Pause the lecture and stare at the scale for 2 minutes without blinking. Because one day I'm going to take it away. Just kidding. You probably freaked out there, didn't you? Now I'm going to leave it up here for the first half of the lecture so you've got ready access to it. I will, however, sometime push you out of the nest, so get ready to fly or die on your own. I recommend taking some time to write the color code down so you can staple it to the back of the head of the person that sits in front of you in class. Now that we're aware of the significance of the colors, let's talk about the significance of the first 3 bands in the 4-band resistor color code. Again, the color code has nothing to do with engineering prefixes. If you can remember this, interpreting the significance of the first three bands is pretty easy. The first band is the first number. The second band is the second number. And the third band is the number of zeros. It's that easy. Let's say you require a 1 kilo ohm or 1000 ohm resistor. Again, we're ignoring the fourth band right now. But let's say you send your lazy lab partner to the storeroom to grab a 1000 ohm resistor, and they come back with 4 resistors with the following color codes. Which one is the 1 kilo ohm or 1000 ohm resistor you need for your circuit? Let's work through this first example together. Brown, black, brown means 1, 0 with 1, 0. Brown, black, green means 1, 0 with 5 zeros. Yellow, purple, orange means 4, 7 with 3 zeros. This is obviously not the 1 kilo ohm resistor we're looking for. Finally, brown, black, red means 1, 0 with 2 zeros. Now that we've interpreted the significance of each of the color bands, then and only then do we put these resistor values into proper engineering format if it is appropriate to do so. 1, 0 with 1, 0 behind it is 100 ohms. Nope, that's not the 1 kilo ohm resistor. 1, 0 with 5 zeros behind it is 1 million or 1 mega ohm. Nope, that's not the 1 kilo ohm resistor either. 4, 7 with 3 zeros behind it is 47,000 or 47 kilo ohms. That's definitely not the 1 kilo ohm resistor we're looking for. Finally, 1, 0 with 2 zeros behind it is 1,000 ohms or 1 kilo ohms. That's the one we're looking for. Dismiss your lab partner with a roll of the eyes and a flick of your hand. Tell him or her to put the first 3 resistors in drawers marked 100, 1 mega ohm, and 47 kilo ohms. Watch them. They'll just dump all 3 resistors in the first open drawer they find. This is why you need to know how to interpret the resistor color code. Trust no one, especially not your lab partner. Notice how 3 of these 4 resistors look kind of similar, and they all start with a brown and a black, or a 1 and a 0, and only the third band distinguishes them. If the third band represents the number of zeros, this means the difference between each color is 10 times. If there's any single advice I can give you is to pay attention to the third band. This is the most important of all the bands. If you're using components 10, 100, or even 1,000 times the values you're supposed to be using, your circuit is not going to work the way you expect it to. The moral of the story? Get a new lab partner. Let's try a couple reps to see if you're tracking before we introduce some of the idiosyncrasies of the 4-band resistor color code. Consider the sample set of resistors. See if you can interpret the first 3 bands and express the nominal or nameplate value of these resistors using appropriate engineering format. By all means, pause the lecture and try this on your own. If you're tracking, you should have obtained the following results. Orange, orange, red is 3, 3 with 2 zeros, or 3,300, or more appropriately, 3.3 kilo ohms. White, brown, brown is 9, 1 with 1 zero, or 910 ohms. Blue, gray, yellow is 6, 8 with 4 zeros, or 680,000, or more appropriately 680 kilo ohms. Finally, brown, black, black is 1, 0 with 0 zeros, or 10. Tricky, eh? Let's try this in reverse. See if you can determine the color code of the first 3 bands of the 4-band resistor color code for this selection of resistors. 51 kilo ohms, 6.8 kilo ohms, 470 ohms, and finally 1.8 mega ohms. By all means, pause the lecture and try this on your own. If you're tracking, you should have obtained the following results.